This video is about measures of dispersion. First of all, what does dispersion mean? It means the spread of the data. How far out is it? How much does it vary from one value to another? So the measure of dispersion is used to describe your data set. Another way to think of dispersion is how spread out is the data. The common measurements that you see used with dispersion is range, IQR, variance, standard deviation. And I'm sure you've heard of all of these measurements before. I know we talked about IQR a little bit in our last lesson, but we're going to talk about it again in this particular lesson. As we talk about these other measurements for dispersion. We're going to talk about one of the simpler ones, range, first of all. So when we talk about range, this is just simply the difference between the highest and the lowest value. Difference, of course, means that you are subtracting them. So if we were to look at a formula for range, it would just be the max value minus the min value. There is no notation for range, so it doesn't have a variable or some kind of symbol to represent range. So we don't have some way to abbreviate that, so just finding the range would be the max minus the min. Now, what does it tell us? It tells us how spread out the data is. So a large range value would tell us that the data is widely spread out. A small range value would tell us that the data is close together. Now, what are some advantages of using the range as a measurement as we look at data? Of course, one of the advantages is that it isn't super easy to calculate, very quick. It's easy to pick out the largest value. It's easy to pick out the smallest value. Another advantage is not only easy, but it's very quick to calculate. Doesn't take long at all to calculate the range. Some disadvantages, however, is that it is not resistant to extreme values. And of course your extreme values are on the end. They're either high or low. And since you're using your max or your min to calculate your range, obviously you're going to be using your extreme values. So obviously they're going to be used when you calculate your range. Let's look at an example problem. We have some temperatures in Honolulu. The hottest day of the year. The temperature was 89 degrees Fahrenheit. And the coldest day, the temperature was 61 degrees Fahrenheit. So we want to figure out what is the range. And of course we're simply going to do 89 minus 61, and that tells us that the range is 28 degrees. Now let's do another example where we're looking at two different data sets. So we have data set A and we have data set B. So in data set A we have the values 1, 2, 7, 12, and 13. In data set B we have the values 5, 6, 7, 8, and 9. Now, when we look at this particular data set, for each of these data sets, the mean and the median are the same. So we're needing another value to help us distinguish some information about these two data sets. So when we calculate the range on the first data set, the highest minus the lowest would be 13 minus 1. So the range on that first set is going to be 12. And we calculate the range for the second one, which would be 9 minus 5. And so that range is 4. So what does that information tell us? Even though the mean and the median are the same for both of those sets of data, this range information tells us that data A is more spread out than the second set for data set B because of that range value being so much larger than the range in the second set. So that's how using the range can help us know some additional information about our data.